Hello programmers, Dan McElroy here with a discussion on how to read and write random access files while simulating an automatic teller machine. This is not a program I would expect first semester students to write on their own. This project simulates an embedded automatic teller machine system as opposed to a typical user application on a computer. The programs running on embedded systems typically are started automatically when the power is turned on and do not end until the power is turned off. There is a while loop that is coded to run forever, such as while, open parentheses, true, close parentheses. Since there is nothing to code in the program, you will need to end it either through the IDE or click the red dot or the X on the program's title bar. Here is a list of topics covered in this presentation. 1. Files in the project. 2. Sample run of the ATM program. 3. Program organization, inherited classes. 4. Data file descriptions. 5. Accessing disk files with Java. 6. Analysis of the Java ATM code includes the lab project. The project files are located at https://program-info.net/java/atm and watch the capitalization. There are 3 Java code files and 2 text-based data files. The Java ATM.java source file contains the main code for the ATM project. It has the code to process a withdrawal or deposit at an ATM. Customer accounts.txt file is a readable text file that contains records for each customer and their account balances. Customer names.txt is a readable text file that contains a cross-reference between customer account numbers and their names. Here are the 5 files for the Java ATM project when using onlinegdb.com. Click the New File button at the upper left corner of OnlineGDB to add each of the 5 files. Rename the files as needed, making sure that Java source code files have the exact same name and capitalization as the class definitions and have the .java file extension. Remove or comment out the package Java ATM statement at the top of each Java file when using OnlineGDB. Click the New File button and add each of the remaining files to the project. Once the files have been added, you can click the Editor tab to see each file. Here are the 5 files for the Java ATM project when using Eclipse. When I created the project, I named it Java ATM with a small j. You can name it anything you want. I also named the package Java ATM with a small j. Make sure the package statements at the top of the Java source code files have the same name as the package. The txt data files need to be placed in the project folder. If they end up in the package folder, use the mouse to drag and drop them into the project folder. Click the New File button and add each of the remaining files to the project. Once the files have been added, you can click an Editor tab to see each file. Here is the Java ATM program using OnlineGDB. Here is the Java ATM program using Eclipse. Now let's run the program. The program starts out with a welcome message and a prompt to either enter an F to display the customer data file, or a Q to end the program, or a customer account number. I can see the list of customers either by opening the customer.txt file in the editor or by entering F at the prompt. I selected account 6114878 and then its PIN 1781. A personalized welcome is displayed. Greetings, John. How can we help you? Enter B to show the balance for both checking and savings. I need to enter Y to continue with the same customer, or N to start a new transaction with a different customer, so I'm entering Y. Enter W to withdraw, C to select checking, and 100 to withdraw $100. My new updated balance is $906.40. I click Y for another transaction with the same customer, D for deposit, and then 100 to deposit $100 back into the account. Wow, my balance is back to $1,006.40. Cool for me, but it won't work for you. You need to write the code for the deposit. class Java ATM, open close parentheses, class customer record, open close parentheses, and class customer names, open close parentheses, are each in their separate Java source files. Modular programming techniques are used to divide the Java ATM program and separate it into several self-contained units. This makes it easier to maintain and debug. This is called divide and conquer. The Java, open close parentheses, class file has 9 separate modules. I encourage you to look over the code in each of these modules to see how Java implements the code to complete each of its tasks. More detail for each of these modules is presented later in the discussion. The deposit module is outlined in red because it has no code. It is up to you to write the code for this module. The names of each module in class ATM are search for customer, process transaction, display file, display balances, withdraw, deposit, and select account. There are 2 helper modules also included, getInt and getDouble. Class customer record, open close parentheses, contains variables that can hold the data for one customer record from the customer records.txt file. Getter and setter methods are provided to give access to this data by the Java ATM class. Class customer name, open close parentheses, is similar to class customer record, open close parentheses, but it holds data for one record from the customer names.txt file. The customer accounts.txt and customer names.txt data files are stored as ASCII text character strings. A big advantage to storing data as text is that it can be read by any text editor application. A disadvantage is that any numeric data must be converted from a text string into either binary integer or double data types before any math operations can be performed, such as when adding deposits or subtracting withdrawals. Then the result needs to be converted back to text before writing it back to a text-based file. There is a customer record on each line in the customer accounts.txt file. Each customer record has 4 fields: account number, PIN, checking balance, and savings balance. For this project, entering the account number represents inserting the card into the ATM. The file is sorted according to the customer account number. This would provide the opportunity to do either a sequential or binary search when looking for the customer account. However, since there are only 26 customer records, the code for this project only uses the sequential search, starting at the first record and going down one record at a time until a match is found for the account number and PIN. The first field in the customer names.txt file is the customer's account number. The next 2 fields contain the customer's first and last names. The file is sorted according to the customer's last name. There is an identical account number in both customer accounts.txt file and the customer names.txt file. This slide shows a disk dump of customer accounts.txt, which is a text file containing ASCII characters. The first column of the display shows the offset into the file expressed as a hexadecimal number starting with 0000 and then 0010 and 0020 and so on. (0010) in hex is 16 in decimal. Each line of the dump shows 16 bytes of data, expressed as 2 hexadecimal characters each. The second column shows the printable ASCII characters that are in the file. Non-printable characters are displayed using a period. This includes space characters and the 0D and 0A control characters for carriage return and line feed at the end of each line. If the data would have been created using text editor on a Unix-style computer such as Linux or Mac OS, only the 0A line feed code would have been entered at the end of each line. The third column has the binary data expressed as a hexadecimal number. Looking up a hex 31 on the ASCII chart, it gives the printable character 1. Looking at the next byte, hex 30 gives the printable character 0. And for the next, hex 39 gives a 9. The hex 2E, ASCII code for a period. Now it's time to start decoding the second customer's record. I hope you found this at least a little bit interesting, because it will become very useful to you in the future as a programmer. Source code for the disk dump program can be downloaded from https://program-info.net/c++/downloads/c++diskdump.cpp. A customer transaction starts when the account number and PIN are entered. If the account number is found and the PIN is correct, a personalized message appears on the ATM screen with the customer's first name. In this case, "Greetings, Jose," where Jose is the customer's first name. After the customer enters the account number and PIN, the customer accounts.txt file is searched to find a match. The customer names.txt file is searched looking for the same account number. The customer's names is combined into a welcome message. "Greetings, Jose. How can we help you?" This is the beginnings of a relational database that contains multiple files. The account number appears in both files and is considered a key field. Consider this situation. A user opens a checking account at the bank. The checking account information not only contains the account number and all the checking transactions, but also the customer's name, address, phone number, and social security number. Then the customer likes the bank so much, opens a savings account. The savings account contains the account number, all the savings transaction, also the customer's name, address, phone number, and social security number. The customer really likes the bank and gets a car loan. The car loan information also contains the name, address, phone, and social security number. There is a lot of duplicated information since each account contains the customer's name, address, phone number, and social security number. What happens when the customer moves across town and submits a change of address? Suppose it gets updated in the checking and savings account, but not the car loan, and the bills for the car loan never get sent to the new address. With a database, we can keep the personal information about the customer in one file. Each of those other account files just link to the customer information. When the customer's new address is updated, it will show up for any of the accounts that are displayed. Let's add some more information about how Java can access files on the disk. I've separated this part of the discussion into several sections. Different ways Java can access disk files: binary versus text file, open file mode, seek, reading and writing, close a file, and delete a file. Java has several different classes and methods to access a disk. One group of programmers wanted their application to access the disk in a certain way, so they wrote a bunch of code to make it happen. They share their code for other people to use. Then another group of programmers came up with a different way to work with disk files that suited their application a little better, and they shared their code. And then another group of programmers, and so on. I'm only using random access file for the Java ATM project and will only be discussing details for this method. The reason I selected this way is because I want to find a customer's account PIN and balances on the disk, and when processing a withdrawal or deposit, to be able to update the exact same location on the disk with the new balances. Once I've found the data for the selected customer, I don't want to start at the beginning of the file and start a new search in the file each time the same customer selects a new transaction. I want to go back to the same location on the disk as long as I am still working with the same customer. The rest of the access methods shown here are great if you want to start at the beginning of a file and keep moving forward and don't need to move around to different locations in the file. This is typically referred to as a stream of data. It is like a stream of water that starts in one place and flows downhill, but the water does not jump back and forth. Opening a file creates a connection between the file on the disk and the program. The file can be opened for reading, writing, or both. When opening the file for writing, it can be opened for appending, which means the data will be added to the end of the file instead of the beginning. A lock is placed on a file, especially when it is opened for writing, to prevent another program from also trying to write to the file at the same time. The file needs to be closed when the program is finished working with it. This allows other programs to have access to the file. Some programs, such as C and C++, will automatically close the file when the program ends. Other programs leave the file in an opened state when the program ends. This can cause problems when another program wants to use the file. It is best practice to make sure you close a file even if you're writing a program in C or C++. The file pointer, sometimes abbreviated as FP, keeps track of the current location in a file where the data is to be read or written to the disk. The file pointer is advanced to the next location when data is read or written. The file pointer can be saved in a program as a long data type or possibly data type specifically created to hold the file pointer. When searching for a record in a file, first you need to get the account number or name or whatever it is you're searching for. From this point on in the discussion, I am assuming that we will be searching for an account number in the ATM data file. With a sequential search, you start at the beginning of the file, read a record from the file, and compare the search account number to the account number from the file. If they match, then you have found the customer's record in the file. If they don't match, then you read the next record in the file and see if there's a match. This read next record and compare continues until a match is found or the end of file is reached without finding a match. Once a record has been found, keep track of the position in the file for future operations on that record. By knowing the record number, a seek command can be issued to return to the same customer record. Most file access methods have a rewind command that positions the file pointer back to the first record. Another way to get to the first record is to close the file and then reopen it again. The random access file class has several methods for working with files. The list at the top of the slide shows the ones that are used in the Java ATM project. The random access file, open parentheses, file name, comma, quote, R, quote, close parentheses, constructor shows opening the file in read mode. Or random access file, open parentheses, file name, comma, quote, RW, quote, close parentheses, in read and write mode. The RW mode is needed when processing a deposit or withdrawal. First, to determine the balance for the checking or savings, and then update the balance once a transaction is completed. The getFilePointer, open close parentheses, method is random access files version of the tell function, which obtains the location of the file pointer for the current customer's record to read the balances using the readLine method. After the balances have been updated for a deposit or withdrawal, the seek method is used to bring the file pointer back to the same customer record on disk so that the disk data can be updated using the writeBytes method. The close method is used to close the file and release the disk from the Java ATM application program. This list here shows only a few of the many other methods available for use with the random access file class. You can get more complete list at either the Tutorials Point or Geeks for Geeks website at these URLs. The Tutorials Point website shows many methods on a single web page. The Geeks for Geeks website uses about 3 web pages but gives a fuller description for each method. A lot of information has been provided in this presentation. A simulated automatic teller machine, building a multi-file project that accesses 2 data files, working with random access files, searching a data file. Credit for the ATM image goes to http://depositphotos.com/stock-photos. See you next time. Dandolph, signing off for now.